So the diagram shows a wooden beam of negligible weight. So basically this is a wooden beam. There is a weight of the beam, but that is negligible. When they say negligible, it means you don't have to consider. That's why we did not draw an arrow to show the weight of the beam. Then the man is walking on the beam. The weight of the man is acting, or weight always act downward. So weight of the man is equals to 800 Newton. We have to calculate the distance between the man and the pivot, that is unknown. This is x. And they mention the length of this beam, the total length of the beam is equals to 3 meters. The force of the rope is there of 500. What is the distance between the man from P when the tension in the rope Q becomes 500 or equal to 500? Tension in a rope means force in the rope, that's equal to 500. So which direction weight of a man is causing the rotation? This will cause a rotation in clockwise. And which direction, if this will try, the tension in the rope will try to cause a rotation, that is anti-clockwise. And because it is in equilibrium, as they mention here, or even if they did not mention, you have to solve these type of questions by considering that object is in equilibrium or object is balanced. So the clockwise moment is equals to anti-clockwise. The clockwise moment, the weight of the man is 800 multiplied by distance from the pivot is unknown, that is x, equal to the anti-clockwise moment, the force is 500, and the distance, what is the distance of this 500 force from the pivot? The total distance is 3 because the length of the beam is 3, so total distance is 3. 800 is multiplied, other side it will divide, so 500 multiplied by 3 divided by 800. So when you solve this, you will get 1.875, which is approximately equal to 1.9. That is why C is the right answer. Is it clear, this question? So now we'll do more questions related to the turning effect or a moment. Okay, in this question, in a braking system of a car, this is a picture from a braking system of a car. The brake pedal rotate about a pivot. So this is a pivot is given. When the pedal is pressed, as shown in the figure, so when the pedal is pressed, it will rotate about the pivot. The driver exert a force of 200. So driver is exerting a force of 200 on a pedal at a distance of 22 centimeter from the pivot. So this distance is 22. As the pedal rotates about the pivot, a force is exerted on the piston and the pressure of the oil increases. So force is exerted on the piston and the pressure of the oil is increased. The area of the piston is given 5 exponent minus 4. Calculate the force on the piston. So how we can calculate force on the piston? So first we have to work out the direction in which they can cause a rotation. If this is a pivot, a 200 Newton force, which direction this will cause a rotation? A 200 Newton force, clockwise or anti-clockwise? So that is clockwise. Then there is a force, this force, which direction this will try to cause a rotation? The unknown force F, force on the piston. So that will try to cause an anti-clockwise rotation. So whenever we are solving a question, we always assume that it is in equilibrium. So when it is in equilibrium, we assume the total anti-clockwise moment is equals to total clockwise movement. So the force which we are applying, that is F, multiplied by distance from the pivot. What is the distance? What is the distance from the pivot for anti-clockwise moment? The force is F, the unknown, and the distance from the pivot is 8 centimeters. So that is 8. Equal to clockwise moment, the force is 200 multiplied by distance from the pivot. So this total distance, that is equals to 22. Whenever I told you, whenever we are solving a question related to this, if they did not mention, we have to assume that it is balance. And whenever we assume it is balanced, it means we have to consider it is in equilibrium until unless they mention. So whenever you are solving a question related to a turning effect, you have to assume it is balanced or it is in equilibrium. So it will be 200 multiplied by 22. 8 is multiplied, other side it will divide. So it will be 200 multiplied by 22 divided by 8. What is our final answer for the force? 200 multiplied by 22 divided by 8. So that's equal to 550 newtons. Is it clear, this part? Okay. Another question. Two mechanics are there, A and B, are trying to use 2% spanner or a wrench to loosen a nut. So they are using a 2% spanner to use on a large wheel. Figure 2.1 shows the force exerted by the two mechanics. So mechanic A is exerting a force of 500 downward and mechanic B is exerting a force of 400. Mechanic A exerts a force of 500 at a distance of 1.2. Mechanic B is exerting a force of 400 at a distance of 1.2. Calculate the magnitude and the direction of resultant moment. So when there is a resultant moment, means it is not in equilibrium, one of the moment will be higher than the other. Now how to calculate? First, this is a pivot, a point of rotation, because they mention here around point P it is rotating. So it is a pivot. Which direction mechanic A is trying to cause a rotation? Clockwise or anti-clockwise? So mechanic A is trying to cause an anti-clockwise rotation. And mechanic B is trying to cause a clockwise rotation. Now, what is the anti-clockwise rotation? When we calculate the total anti-clockwise rotation here, that is 500 multiplied by 1.2. So 500 times 1.2, that's equal to 600 Newton meter, because it's 500 multiplied by 1.2. Then the clockwise, and it is a moment. When it's a moment, it should need Newton meter or Newton centimeter. If it was a force only, then it will be Newton. A mechanic B is exerting a force of 400 and the distance from the pivot is 1.2. So 400 multiplied by 1.2, that's equal to 480 Newton meter. So this is anti-clockwise and this is clockwise. So when two moments are acting in opposite direction, as we did yesterday, if they are in opposite direction, two moments, what we do, we subtract. So one is 600, another one is 480. So the resultant will be 600 minus 480. So what is the result? It is 120 Newton meter. But what about the direction? Which direction it will rotate? The direction of the higher moment, because anti-clockwise moment is more, so direction will be anti-clockwise. Is it clear, this question? Then the next part, calculate the magnitude and direction of resultant moment exerted by the mechanic. What they mentioned, that we did. Now mechanic B reverses the direction of 400 Newton force. So what mechanic B is now doing, he reverses the direction of the 400 Newton force. So first he was applying a downward force. Now the mechanic B is applying a upward force. So we know mechanic A is causing an anti-clockwise rotation. As the mechanic B changes the direction of its force, so now he will also cause an anti-clockwise moment. So the moment produced by mechanic A, we already calculated, that was 500 multiplied by 1.2, that's equal to 600 Newton meter. And mechanic B, the force is 400, distance is 1.2, so that was 480 Newton meter. But now it is anti-clockwise and A is also causing an anti-clockwise. So what is the resultant moment now? If two moments are acting in the same direction, so what we do? We add them. So resultant moment will be 600 plus 480. So that is equals to 1080 Newton meter anti-clockwise. Is it clear, this part? As they mentioned that mechanic B now reverses the direction of the force. So as he reverses the direction of the force, the direction of the moment or turning effect will also change, and we can work out that both moments are in the same direction, so we should add them to get the resultant. But what about the resultant force here? If I say what is the resultant force? What about the resultant force? 500 is downward, 400 is upward. So resultant force will be 500 minus 400, that's equal to 100. And what is the direction? The 100 Newton down. Because in the next part, in part B2, they ask that calculate the magnitude of new resultant moment. So what is the new resultant moment? That is 1080 Newton meter. Calculate the magnitude of resultant force now exerted. So 500 downward, 400 upward. So resultant will be 100 newtons. Is it clear, this example? This is a similar question which we discussed yesterday. Another question, figure 2.1 shows a uniform plank. When they say uniform, it means the weight is there at the center. So weight is acting at the center. The length of this plank is 2 meter. And they already give you the weight here. Weight of the plank is shown 210 Newton. The weight of the plank is 210. The force in the rope X is P. So rope X is exerting P and rope Q is exerting a force. Rope Y is exerting a force Q. In terms of P, the moment of force about B, when they use the term about, it means what is the point? which is a pivot. So B is the pivot. So where is a pivot in this example? Because we mentioned here about B, so what we are considering a pivot, we consider this point as a pivot. So we have to state in terms of P the moment of force P about B. So about B means B is the pivot. And what is the moment caused by this force P? So moment is a product of force into distance. So what is the force here? The force is P. And what is the distance from the pivot? Distance between the force and the pivot, that's equal to 1.5. So it will be P multiplied by 1.5. Is it clear that we have to just write an equation to show a relation between or P and the moment produced by this P? The next part, calculate the moment of weight about B. So how to calculate the moment of weight about B? When they say about, it means B, this point is the pivot. So point B is a pivot. The force of 210 Newton. And this is a uniform plank. So if it's a uniform plank of total length of 2 meter. So if this uniform plank is having a total length of 2 meter. So where the weight will act from the center, it will act at the center. So it will be 1 meter from both sides. So how to calculate a moment of W about B? So moment of W about B, moment is equals to force into distance. So force or weight multiplied by distance. So what is the distance between the weight and the pivot? That's equal to 1. And weight we already know that's 210. So this will be 210 multiplied by 1. So moment will be equal to 210 Newton meter. Is it clear? The second B1. Then the third part, we have to calculate the force P. How to calculate this force P? So we will consider it is balance or equilibrium. If B is the pivot, which direction this weight will cause a rotation? Clockwise or anti-clockwise? The weight W, which direction W is causing a rotation or trying to cause a rotation? Clockwise or anti-clockwise? So that is anti-clockwise. Which direction this force P is trying to cause a rotation? Clockwise. Which direction Q will try to cause a rotation? Q is acting on the pivot, directly acting on the pivot. Will it cause any rotation? So it will not cause any rotation because it is acting on the pivot. When force is acting on the pivot, it does not cause any kind of rotation or turning effect. So as we consider it is balance or it is equilibrium, so the total clockwise moment is equals to total anti-clockwise moment. Clockwise moment, the force is P multiplied by distance from the pivot because about B, so that's 1.5. And anti-clockwise moment, that is 210, the weight, multiplied by distance from the pivot, it is 1 meter because it is acting at the center, total is 2. So half will be 1. So when we solve, 1.5 is multiplied, other side it will divide. So 210 multiplied by 1 divided by 1.5. So what is the final answer? 210 divided by 1.5. So we'll get this force, which is equals to 140 Newton. When it's a force, it is Newton. Is it clear, this part? 140 Newton. Then the last part, we have to calculate force Q. How we can calculate force Q? Look, we already calculated force P. Now force P was 140. As we consider it is in equilibrium, it is balanced. 140 Newton is acting up, force Q is acting up, and weight is 210 acting down. When it is balanced equilibrium, the upward force equal to the downward force. So upward force is 140 plus Q, and the downward force is 210. So upward force equal to downward force. We need Q. So Q is equals to 210 minus 140. That is equals to 70 Newton. So basically Q is equals to 70 Newton, which is acting upward, so that this beam is in equilibrium. Is it clear, this part? Anyone having a doubt? So these type of questions we solve when we consider the object is balanced or object is in equilibrium. Figure 4.2 shows another elephant pushing horizontally against a vehicle with a force of 11 kilonewton. 11 kilonewton. Question 4 or question 3, Abdullah? This was question 3. Abdullah Sarfraz. Look, in question 3, in the first part, they're asking, figure 2.1 shows a uniform plank which is having a length of 2 meter. So if it's a uniform plank, the weight will act at the center, which is 1 meter from both sides. The weight of the plank is 210 Newton. The rope X exerts a force P and the rope Y is exerting a force Q. State in terms of P the moment of force P about B. So we have to calculate a moment produced by this force P about B. About B means if B is a pivot. So if point B is a pivot, we want the turning effect of this force. So how to calculate a turning effect of the force? Moment, that is force multiplied by perpendicular distance. So what is the force applied here? Abdullah, I want you to use your mic so I can clear each part for you. What is the force we are applying with rope X? Yes, Abdullah. Abdullah Sarfraz. I want you to use your mic. Sime, here in the question they mentioned it is a uniform plank. So when it is a uniform plank, it means the weight will be there at the center. So if the total length of the plank is 2 meter, So the weight will act at the center, which means 1 meter from both ends. Yes, Abdullah Sarfraz, use your mic.
Yes, sir.
Look, in this part, we have to state in terms of P the moment, the turning effect of force P. So how to calculate a turning effect? The turning effect, the moment is the product of force and distance. So what is the force we are applying?
Like, what do you mean, sir?
The force we are applying by rope X. They mention here the force in rope X is P. So what is the force exerted by rope X? That is equals to P. Multiplied by, because we are calculating a moment, so moment is force multiplied by distance. So force exerted by rope X is P, and the distance between the force and the pivot, because B is the point of rotation, that is 1.5. So it will be P multiplied by 1.5. Is it clear, Abdullah? The first part.
Yes, sir.
Now about the second part, they're asking the moment or turning effect of the weight about B. So we want a turning effect of this weight about B. So how to calculate a moment? Moment is force multiplied by distance. So force is equals to 210 multiplied by distance. So what is the distance here? The force is 210. And what about the distance? Because the weight is acting at the center. So weight is having equal distance from the center. If the total length is 2 meter, so half the length will be 1 meter. So 1 meter from left and 1 meter from right, the weight will act at the center. So what is the moment or turning effect of the weight? It will be 210 multiplied by 1. So that is equals to 210 Newton meter. Saim Ahmad, I want you to use your mic. This was your question by mistake. I thought it was Abdullah. Saim,
Yes, sir.
the second part, we want to calculate the moment or turning effect of the weight about B. When we say about B, it means B is a pivot. So what is the force here? The force is 210. And what about the distance between this force and the pivot? Because the weight is acting at the center, so weight will be at
Okay, sir.
1 meter away. So it is 210 multiplied by 1. So that is 210 Newton meter. Is it clear?
Okay, sir. Yeah.
Then the next part, we want to calculate the force P. So how to calculate a force P? We will assume it is a balance or equilibrium. This is a pivot. So which direction weight is causing a rotation, clockwise or anti-clockwise?
Clockwise.
Wait. If you check this direction, is it same as the direction in which the hands of a clock rotate, or it is opposite?
Opposite, sir.
So it is anti-clockwise. And the force P is there. Which direction this will cause a rotation? It will cause a clockwise rotation. And what about
Okay.
Q? Because this Q is acting on the pivot, it is acting on the same point, so it will not cause any rotation. Why? Because it is acting on the pivot, it does not have any perpendicular distance. That's why it does not cause any kind of rotation or turning effect. And as we
Okay, sir.
assume it is in equilibrium or it is balanced, so whenever we assume it is in equilibrium, anti-clockwise moment is equals to clockwise moment. So anti-clockwise
Okay.
moment is 210, that's the force, multiplied by distance is 1, and clockwise moment is force is P, multiplied by distance is 1.5. So 1.5 is multiplied, other side it will divide. So when you solve this P, it will come out 140 newtons. Is it clear?
Yes, sir.
And
Thank you.
then in the last part, we need Q as well. So because the force P, which is acting upward, it is 140. Force Q, weight is acting downward 210. If it is balance or equilibrium, the upward force must equal to the downward. So 140 Newton, which is up, Q is up, and weight 210 is downward. So if it is balanced, the upward force equal to downward force. So 140 Newton plus Q should be equal to 210, or Q is equals to 210 minus 140. That is equals to 70 Newton. So Q should be equal to 70 Newton upward. Is it clear discussion?
Yes, sir.
Okay. So example, another question. Figure 3.2 shows a uniform rod. So if it's a uniform rod, where the weight will act? It's 1 meter long. So weight will act at the center. This weight will cause any rotation? Yes or no? So it will not cause any rotation. Why? Because it is acting on the pivot. That's why it does not cause any rotation. So the total length is 1 meter. A force of 12 Newton at a distance of 0.3 from support A. A spring S is there, fixed at the lower end and attached to Q. Calculate the force exerted on PQ by the spring. So how much spring is applying a force? So basically the clockwise rotation is equals to anti-clockwise. This 12 Newton, it will cause an anti-clockwise rotation, and this spring, try to pull it, it will cause a clockwise rotation. And what will be the distance between the pivot and this spring? If the pivot is at the center and the total length is 1 meter, what will be this distance? That's equal to half meter or 0.5. PQ is this rod is called a PQ. This is a name. A figure 3.2 shows a uniform rod PQ. This rod is having a name. This rod is called a PQ. So we want to find how much force is exerted by the spring, the force of the spring on the rod. So as we know, if it is a moment turning effect, the clockwise moment is equals to anti-clockwise, and we assume it is balanced. So 12 multiplied by distance from the pivot, that's equal to 0.3, and clockwise rotation, the force F is there, multiplied by distance from the pivot, that's equal to 0.5. 0.5 is multiplied, other side will divide. So 12 into 0.3 divided by 0.5, we'll get this F. So 12 multiplied by 0.3 divided by 0.5, that's equal to 7.2 Newton. So basically this spring will apply a force of 7.2 Newton downward. Then explain why it is not necessary to know the weight of PQ. PQ, the rod PQ. Why we don't have to find a weight here? Like weight can have any number, but why we do not bother about it? Maybe the weight will be 2 Newton, 5 Newton, 30 Newton, but we did not consider. Why? Because this weight is acting on the pivot, that will not cause any rotation. That's why we don't have to bother about. Yeah, Taha, that's a good answer, because it is not causing any moment or turning effect. So we do not have to consider the weight, or we don't have to consider the weight. Is it clear? In the last part, yes, Simon, if it was not in equilibrium, the result will be different. That's why we always consider it is in equilibrium or balance. In this question, they are saying why it is not necessary to know the weight of PQ. Why we don't have to know the weight of this plank or weight of this rod. It can have any number, but we do not consider at all. So why we do not consider at all? Because the weight is acting on the pivot. So it does not cause any rotation. That's why we do not consider the weight of this rod or a beam. Is it clear? The last part, Abdullah, that why we do not consider the weight, because the weight was there acting at the center. So whenever weight is acting on the pivot, we don't bother about the turning effect because it does not cause any rotation or the turning effect. So these are some questions related to the moment. A moment topic, it's you will improve in this topic when you practice the questions, different questions, different types of questions. So in the next session, we'll do more questions related to this topic. Any question or a doubt related to the class today? So I'll end the session and share this recording with you.